So let's take a look at experiment number 7, chemical reactions. Now we have the ability to observe a chemical reaction, classify the kind of chemical reaction we're observing, and balance the equation for the chemical reaction. And we're going to put these skills to the test in this experiment. So we talked about observations for our reaction back in chapter 1. We talked about a reaction which would change colour. That could be a different wavelength of light being absorbed because of a different chemical present amongst the products. That product could also be a solid which is insoluble in the solution, so we could see a precipitate being produced. If you're holding the test tube might feel hot to the touch because the reaction is giving off energy. That's what we call an exothermic reaction. Or the test tube or flask could feel cold to the touch because the reaction is taking in energy, and that's what we call an endothermic reaction. Without sticking your nose in the test tube, you might sense an odour coming from the reaction, or you could see some bubbling, some effervescence in the solution, a sign that a gas is being produced. And we can test for 3 specific gases being produced: carbon dioxide, oxygen, and hydrogen gas. Carbon dioxide, of course, extinguishes a lighted splint, and we can let that CO2 build up in the Erlenmeyer because it's a heavier gas than air, and then pour out the gas to snuff out some lighted candles. A nice party trick. We can also test for oxygen. Take a lighted splint, blow it out, and then stick it into your reaction. It will relight the flame. You should be able to do it several times. We can also test for the explosive hydrogen gas. Now the first experiment will be in the fume hood at the back of the room. That's a combination reaction between magnesium and oxygen to produce magnesium oxide. We can also think about this reaction as a combustion reaction because oxygen is one of the starting reagents. Next, you're going to have a decomposition reaction of hydrogen peroxide. Decomposes in the presence of the catalyst manganese dioxide to produce water and oxygen gas. We can test for that oxygen gas. Next, a single replacement reaction between aluminium and copper chloride. Remember, it's like swapping with like, so the aluminium swapping with the copper. So we produce a solid precipitate of copper, which should be visible, and aluminium chloride. Another single replacement, zinc, this time replacing with hydrogen. Remember, hydrogen is like a metal sometimes because it's in the alkali group 1. So hydrogen replaced by zinc, so we produce zinc chloride and hydrogen gas. And again, we know how to test for hydrogen gas. Now the setup for the experiment with zinc and hydrochloric acid is a little bit different from what you're used to. You're going to set up as we see in this picture. Take that Erlenmeyer and put a stopper in the top once your zinc and hydrochloric acid are added. There's a tube from the Erlenmeyer, that side arm, which leads to the bottom of the water bath. That's where the hydrogen is going to progress from the Erlenmeyer to the collection flask, which is a grey bottle. Fill up that bottle with water to the brim, put a stopper in, then put it under water upside down. You can then safely take out the stopper without the water flooding out. And then when you're ready to start the reaction, you can count for 20 seconds once the reaction starts. First, you've got to get rid of that air, which is in the Erlenmeyer. After about 20 seconds, slide the reaction vessel over to collect the hydrogen gas. Once it fills, put the stopper back on while still under the water, and then you can take it out of the water bath, leave it upside down, and wait for the combustion of the hydrogen. Next, we have some reactions with lead nitrate. These are all double replacement reactions: lead replacing potassium, lead replacing hydrogen, and lead replacing potassium again, producing some nice colourful precipitates of lead chromate, lead sulfate, and lead iodide. We also have some reactions with sodium bicarbonate, nowadays called sodium hydrogen carbonate. Sodium hydrogen carbonate is a base, and we can heat it up to perform a decomposition reaction as it transforms into sodium carbonate and produces carbon dioxide and water. We can also perform an acid-base reaction with hydrochloric acid. The hydrogen carbonate picks up a proton, the hydrogen, so that we can produce carbon dioxide and water, and the leftover bits of sodium and chlorine come together to form sodium chloride. Finally, we have a double replacement reaction with sodium hydroxide. Copper switching with sodium, iron switching with sodium, so we can produce copper hydroxide and iron hydroxide during the reaction. Remember, if you need help, just ask.